When representing circuits on paper, we want to keep things very simple in terms of our diagrams. And when we draw a diagram of a circuit, we call this a schematic drawing. It's spelled as such, schematic drawing. And so when we represent these items like a battery is very simple to draw. It's just two parallel lines, a short one which represents the negative terminal and a long one which represents the positive terminal. Light bulb is just a swirl, and it has a circle around it. The swirl represents the filament inside the light bulb, usually made up of tungsten. And then a resistor is a jagged line. It looks like it would resist things. It looks kind of like a speed bump. And so when we draw a picture or a schematic drawing, here's a single light bulb in connection with a battery. Here's what it would look like. We draw our wires in a nice box shape. And so in this schematic drawing, as long as our device, in this case a light bulb, has both ends touching opposite sides of the battery, the object will stay lit. We call this a closed circuit. If we have a break in the wire, we have a gap in the wire, then the object will not light up. In this case, the light bulb will not light up because both ends do not touch the battery. So although the right-hand side touches the battery, the left-hand side does not. And we call this an open circuit. So when your lights are on, it is a closed circuit. When your lights are off, the switch opens the circuit, the switch creates a gap, and that's why they do not stay lit. Now we can connect, if we have more than one light bulb, we can connect these light bulbs in two different ways. The first way is in series. If we connect light bulbs in series, there's one complete path, one loop. And if we disconnect one of the light bulbs or unscrew one of the light bulbs, all the other light bulbs will go out. The second light bulb, although the bottom part still has a connection to the battery, the top part does not. And so it is an open circuit. There's a gap. And so therefore the second light bulb also goes out. Same thing for the third light bulb. Although the left-hand side touches the battery, the right-hand side there's a gap. And so therefore it's an open circuit, and that light bulb does not light up either. In a series circuit, all the currents are the same. There's nowhere else for the electrons to go, so conservation of charge. The electrons have to go through all three light bulbs, and so all the currents are the same. It's kind of like a single lane when driving. All the cars are pretty much moving at the same speed, so all the currents are the same. We designate the current supplied by the battery as just the letter I. All the other currents we designate whether it's the first resistor, second resistor, or third resistor. Now we calculate something called the equivalent resistance. This says if I were to replace all three light bulbs with just a single light bulb, and I would get the same current from the battery, what resistance would that single light bulb have to get the same current from the battery? We refer to this as the equivalent resistance, because that one light bulb would have an equivalent resistance of all three together. So in other words, it is the total resistance of all the electronic devices in our circuit. Now for a series circuit, the equivalent resistance is simply the sum of all the other resistors added together. One of the things that we use to help calculate and figure out different values within a circuit is Kirchhoff's voltage law. Kirchhoff's voltage law says that all the voltage drops and gains across a closed loop equals zero. So when we talk about voltages, a battery, for our purposes, are going to be a voltage gain. And we're only going to deal with single batteries. So in all of our situations, it's a voltage gain. Battery could be a voltage drop, but that's for a later discussion. So for now, all batteries are going to be a voltage gain. And all resistors or light bulbs will be voltage drops. And we say it's a voltage drop or voltage gain across the device. So the Kirchhoff's voltage law applied to a series circuit is really saying that the voltage drops across each light bulb is equal to the voltage gain of the battery. So this is an excellent way to check your work. The voltage drop across each light bulb is equal to voltage gain across the battery.